This is an Automation Monthly podcast with Phil Zito, episode 166. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly podcast. And in this week's episode, we are going to be starting a new series on HVAC control. So we're going to be talking through HVAC systems. We're going to be talking through specifically space control. Then we're going to move to air handling systems. We're going to move through hydronic systems, and then we're going to talk through some pumping and piping. So that's what we're going to be covering over this. I believe it's going to be a 5-part series. I realize, surprisingly, we haven't spent a lot of time talking about the HVAC side of building automation. So that shall be corrected now. All right, this week's episode is sponsored by our Control Sequence Fundamentals course. If you like what you hear in this episode, we've created a soup to nuts course that takes you through multiple different sequences of operations, explains all the controls theory and equipment knowledge behind these sequences, how they work, how you control them with programming, how you control them with your building automation system. We go really deep into all of those topics. So if you find that you're coming into building automation and your HVAC knowledge maybe isn't quite where you want it to be, then this course would be perfect for you to take. And you can find out more information about that at buildingautomationmonthly.com/166. You scroll down, you see the Control Sequence Fundamentals logo, click on that, and you'll be able to find out more about the course. All right, so as I mentioned, in this series, we are going to go through space control, air handling systems, etc., etc. So focusing in on space control, and the reason I like to start with space control is whenever you think of HVAC and you think of the systems that we are often controlling as building automation professionals, you want to start with a systems approach, right? And you think about it from a modular systems approach. We have spaces. Spaces are conditioned by typically air conditioning equipment, right? Air handlers, rooftops, etc. Those air handlers and rooftops, as long as they're not DX and electric heat, are typically being conditioned by hydronic systems, hot water and chilled water, and those hydronic systems often are flowing via piping and pumping systems. And so when we look at HVAC, I like to start with the most simple of systems and then expand from there. So when we think of space control, which in our world of BAS, that is our primary unit, right, is a space. We tend to control a space. We put a thermostat or a humidity sensor or a CO2 sensor or a pressure sensor in a space, and we control a variety of variables. Which brings us to the topic of what are the most important variables in space control. There's often a lot of conflict about this. Folks are like, well, I want to control pressure, or I want to control temperature, or I want to control humidity. But none of that matters if we don't control airflow, because we can be controlling whatever we want to temperature or humidity, but if we don't have any airflow regulation into the space, then we are not going to change those variables. Because one of the most important things to realize when you're a controls technician, whether you're on service, whether you're an install job, whether you're in sales, when you're looking at a space, if you have an issue with a space that you're trying to control, then that issue should first focus in on the airflow. Because if you don't have proper airflow in the space, both from a supply and an exhaust perspective, it doesn't matter what you do, you're going to be unable to control all the other variables. So how do we control this thing called airflow? As you start to look at building automation and as you start to look at the controlling of HVAC sequences, everything is going to come back to this airflow. Once we've got airflow dialed in, then we can start to worry about temperature control. So when we're looking at airflow within a space, right? Airflow quite simply is the movement of air. I mean, that seems pretty obvious, but some folks don't realize that airflow is actually just a mass of air, just like a mass of liquid or a mass of gas. So air is just like liquid or gas. It has mass and it moves and it fills a space and it fills the width, the length, and the height of the space and that makes up the volume of the space. You'll often hear these concepts called air changes, right? And so that is a complete change of that mass of air within that space within an hour. So you'll hear air changes in an hour, and you'll typically see in most spaces, 2 to 6 air changes an hour, depending on the occupancy level. Now, in some cases, instead of going based on space type, you can actually look at occupants, and there's a whole thing about minimum outdoor air and all that jazz. We're not going to get into that too heavily. We do in our course, but just realize that you supply the air in, and this is typically through diffusers, right? You'll tend to see these in the ceiling. Sometimes you'll see them in the floor, depending on if you have an underfloor system. And what you'll do is you'll diffuse air into the space. And then that air exits into the space, it circulates in the space, and then it is exhausted out of the space. So you have kind of two concepts when it comes to exhaust, and those are supply and exhaust in their kind of inner relationship. And that is volumetric matching and volumetric offset. So in the case of volumetric matching, you have these spaces, and don't worry, we're going to get into VAVs and how all this works, but I'm just laying out a bunch of concepts for you right now. But in the case of volumetric matching, you match the amount of air going in and the amount of air going out, and you're basically trying to establish a neutral pressure in that space. Then you have volumetric offset, where you can vary the amount of volume going in and out of air by changing dampers on either the supply or the exhaust side of the airstream. And by doing that, what's going to happen is that now you're going to be introducing pressurization, or you're going to be introducing negative pressurization. So either positive or negative pressurization. Because if you have more air in the space, think about this, right? Picture a cup in your hand, and you start pouring water in the cup, and the cup has like a little tiny hole in the bottom of it that lets some of the water leak out. That's the exhaust. Now you start really pouring that water in. Eventually that water is going to overflow that cup. That little tiny hole is not going to be able to keep up. Well, that would be a positive pressure situation where the mass of water starts pushing out into other spaces. Well, that's the same thing, right? If you put more airflow in a space than you're taking out, you're starting to introduce a positive pressure environment. And so you start pushing things out into other spaces. And this is where you can run into some issues when you're troubleshooting, is you're not taking into account not only the airflow, but also the pressurization aspects of the airflow. So for example, if you have a hallway that is very poorly conditioned and has poor temperature control, and it's really overpressurized, and it is pushing into spaces, and these spaces maybe are underpressurized, you may actually be having issues with temperature, not because of the control of necessarily temperature in the space, but because of all this unconditioned hallway air or less conditioned hallway air that is leaking into these spaces. And there's all sorts of ways you can avoid this. You can mess around with the volume going into the spaces and the volume going out to make sure that those become more positive than the actual hallway. And this is what a balancer should be doing on the job site when a job is first commissioned, or when a job is actually being retrofit. They should be matching all this volume to make sure that the amount of coming in and the amount going out is introducing positive and negative pressure scenarios wherever it's supposed to be. Now, the thing is, how do we do all this, right? How do we go and actually modulate this air? Well, as I mentioned, we have these things called VAV boxes, and we have exhaust fans, and we have exhaust ducts, etc. So in a modern office space, most of the buildings that have variable air volume air handlers, meaning that you vary the air volume, you keep a consistent temperature, and then you vary the air volume. And what's happening, right, is that you've got these boxes, and these boxes have a round damper on them, and they're called VAV boxes, or variable air volume boxes. And they will tend to serve, either a single space or multiple spaces. It just depends on the layout. and they will tend to be driven by a single temperature sensor per VAV. I'm not saying that's the best way to do it. I'm not saying that's how I recommend doing it. I'm just saying on average, that is how it's installed. So you've got this VAV box and it's branching off of a main trunk line coming off of an air handler, right? And then what it does is it balances the amount of air by going and opening and shutting the damper to control to an airflow set point. It lowers the airflow when it wants to raise the temperature, and it raises the airflow when it wants to lower the temperature. On average, sometimes you'll have electric heat or hydronic heat in the VAV box, and in that case, you'll tend to control to a heating CFM. The reason you do that is because you want to maintain a certain amount of airflow across the coil so that you maximize heat transfer. It's not, if you put too much airflow, you're not going to get the best heat transfer. And if you do too little airflow, you're not going to get the best heat transfer. So there's often a heating CFM. And so that's kind of what's going on in these VAV boxes. And that's on the supply side, right? And then these VAV boxes will tend to be branched off to diffusers that'll either be in the ceiling or in the floor. And then those diffusers tend to be balanced as well using either restrictors or variety of different methods that I'm not going to get into. All right, so you've got that right there, these VAVs supplying air. And then you have exhaust. Now, you have a couple different kinds of exhaust, right? You can have just an exhaust fan that's static CFM, it runs, and then you just have to take into account this exhaust fan is always going to be exhausting this amount of CFM, and this is what I need to account for. Or you can potentially have exhaust VAVs that are variable, and these can be tracking using that volumetric matching, or they can be tracking something else like pressure, doing a modulating offset. Maybe it's volumetric offset where you're taking a direct minus from your supply and you're saying supply minus 200 CFM, and that's going to be my exhaust CFM set point. So you've got these systems, right? You've got these VAV systems, and they can, as I mentioned, be variable, but they can also be CAV, which is constant air volume. And this tends to be on units where you're providing constant air volume and you're actually, I wanted to say verifying and validating. I don't even know why I wanted to use those words because it's not at all what the word I need to use. As I was saying, with a constant air volume system, you're often modulating the temperature control and you're resetting the discharge temperature based on average space temp. So maybe it's serving multiple spaces. You've got these constant air volume boxes that are balanced to a certain CFM. And then you're oh my gosh, forgive me if you're listening to this. I keep wanting to say verify. I don't know why I want to say that. So as I was saying, you are going to modulate this discharge air based off of your VAV kind of temperature average that's coming in from all of these VAVs. So you've got multiple VAVs coming off of this air handler, or multiple CAVs rather, constant air volume units. You see how you can start to mix up VAV and CAV and you can use it interchangeably? I mean, I've been doing this for years and I still will do that at times. And it's really important because if you're talking to someone over the phone and you're trying to troubleshoot something and you're like, man, I got to figure out why this is going on. I'm working on this VAV system, and in actuality, you're working on a CAV system. You can start to kind of see where that would cause a little bit of problem. So always make sure that you're communicating the right thing. So with that being said, you've got these temperature sensors on these CAV systems, and they're averaging out in a controller, and then that controller is driving maybe a cooling valve or something to drive to a modulating set point. So at this point, right, we've got our pressure, we've got our airflow. We talked about how we modulate airflow. We talked about how we go and kind of control our spaces. And now we look at, all right, we've got airflow controlled. We've got that dialed in. Now we can focus in on temperature, humidity, and CO2, which are other three variables that we tend to control. So how do we control temperature in spaces? Well, typically we will introduce more cold air. We'll have a min and max, especially on a VAV system, or we will have a discharge air reset on a CAV system. So we introduce more cold air, either by decreasing the temperature or increasing the airflow. In the case of heating, we decrease the airflow, or we increase the temperature, or we have reheat at VAVs. And what you'll tend to see is the reheat will tend to be on the perimeter. That's to eliminate solar loss and solar gain and all. Actually, solar loss, rather, because we don't care about gain. Gain's actually going to be warming up. But that's to prevent loss and basically provide a heat curtain around the exterior of the building, and then the core of the building tends to be cooling only. And sometimes we'll use some form of space heat, like radiant heat along the floor, or maybe in-floor heat. So we have a variety of different ways we can heat a space. Now, that's temperature control. But what about humidity? Now, humidity we tend to do by going and actually wringing out the air using a cooling coil to bring the air to saturation, drain out the water, and then heat the air back up a little bit, actually in the space. And we do that either through just mixing a mass of air with an existing mass of air, or we do that through reheating the air. So it just depends. You can do a couple different ways of a humidity control. Also, you have decusant wheels, if I can say that correctly, that can remove humidity and moisture out of the returning airstream. So we can go and control humidity in the space. And that tends to be our secondary variable that we control. So we tend to control temperature, and then we control humidity, and then you have CO2. Now, some folks will argue that CO2 is more important than humidity. It really just depends on the space. So if you're in an art institute, then humidity and temperature are going to be more important than CO2. But if you're in a classroom, CO2 is going to be most likely more important than humidity, unless there's a lot of electronics in the classroom, in which case humidity may be more important. So temperature is almost always going to be the top thing, almost always. Not always, but almost always. There's some occasions where humidity will be more important, especially in the data center environment. But in most cases, temperature is the most important. Then we have humidity, and then we have CO2. Now, CO2 is controlled. So you've got ASHRAE, off the top of my head, I think it's 62.1. So ASHRAE 62.1, and yeah, because that's your outdoor air ventilation, and 55 is your thermal comfort. So 62.1 is going to tell you, based on space type or how many occupants are in the space, how much fresh outdoor air you need to control. So there's kind of two ways you can do this, right? One is you can go and control the incoming outdoor air at the air handling unit. And this is what we'll cover in next week's podcast. So don't worry if we don't get too deep. We'll be talking about air side systems in next week's podcast. But you could control via minimum damper position. You could control your what's called economizer in your outdoor airflow. That mixes a certain amount of outdoor airflow into the return air stream, considering that this is a mixed air, not 100% air unit. And so you're going and you're providing this air. That's one way to do it. The other way is based off CO2 control, where you reset the damper to drive to control CO2. And so when do you use either one? When you tend to have large swings of variable populations, meaning variable amount of people, like auditoriums, cafeterias, etc., that's when you tend to use CO2 control, because CO2 will allow for that variability. Where you tend to use a kind of constant outdoor air volume approach is when you've got pretty consistent number of people in a space. So if you know how many people are going to be in a space and it's fairly consistent all the time, in that case, you could use a static economizer set point. And this is funny because this is something no one really explained to me early in my career. They didn't explain to me why we use CO2 and why we use minimum outdoor airflow and when we should use which. So like I said, if you've got a variable audience size, a variable population of people, amount of people, you tend to use CO2 because it really reacts quickly to that variable amount of people and how much CO2 they're putting off. Now, if you have a static amount of people, that's when you can tend to use min flow. Now, with that being said, you can actually use both. I don't recommend using both. I recommend using either or, but you can use both. So there you have it, folks. That is a primer on space control. And I know it was pretty high level, but this should at least give you an idea on some things that you can go and start to think about when it comes to controlling your systems. This should give you some clarity on what's actually going on in the space and what you need to think about as a building automation professional. Now, like I said, if you want to go fairly deep into HVAC control and really understand how all this works and how you control it and look at real live sequences and actually see how these sequences play out and understand everything you'll have to control, the set points you'll have to control, the process variables, etc., I encourage you to go and look at our control sequence fundamentals course. That is what it covers, and it does a really, really good job. We've got a lot of positive feedback about that course and how it's helped folks. And I encourage you to go to buildingautomationmonthly.com/166, scroll down to the control sequence fundamentals logo, click on that, and look at that course. So with that being said, thank you so much for being here for this week's episode. I hope you've liked the kind of shorter format here. I hope it's helped you out. If you have any questions about anything we've covered in this episode, please do not hesitate to go into the comments section and ask. And if you're watching this on YouTube, make sure you subscribe, and as well, make sure that if you have any questions, you leave it in the comment section below the video. Thanks so much, and I look forward to talking to you in next week's episode where we're going to talk through airside systems. And just a heads up, that's probably going to be a longer episode just because there's so much to cover in airside systems. That being said, thanks so much for being here. I can't wait to talk to you in next week's episode. Take care.